So in this video, we're going to talk about how to graph polynomial functions in any form. So if a polynomial function is not in factored form, you need to factor it in order to be able to graph it. So in order to factor the polynomial, we're going to need to use something called the rational root theorem. So a rational root tells us that we can find roots of a polynomial p of x by figuring out p over q, where p are the factors of the constant term, which is a0, and then q are the factors of the leading coefficient, an. Now, which of these roots are actually the solutions? Well, what you can do is you can check them using synthetic division. Remember, synthetic division is a way to divide polynomials without having to do long division. So what you would do is you would write the possible roots in this upper left-hand corner, and then you list out all the coefficients of your polynomial, right? So these are all the coefficients of your polynomial in standard form. Remember that if you skip a term, so for example, if you have a polynomial that's like x cubed plus 2x squared minus 5, you can see here that the linear term has been skipped. Remember that you need to add in a 0 as a placeholder. Okay, so this has to be written in standard form. So what you do is you just bring down the first coefficient, and then you multiply this root, the possible root, times that number, and then you put this number here. So that's how we got 10. 5 times 2 is 10. And then you add these two terms together, you get 4. Then 4 times 5 gives us 20. 20 and negative 23 is negative 3. Then negative 3 times 5 is negative 15. Add together 16 and negative 15, we get 1. And finally, 1 times 5 is 5. And then negative 5 and 5 is 0. If you get a 0 right here, okay, remember 0 is like the remainder, that means that it is a root. Okay, so that means that 5 is a root of the polynomial. If you get anything other than 0 in that final term, then that means that it is not a root. Remember that once you've done this, you can write it's called the depressed polynomial because it'll go down by a degree of 1. So this original polynomial would have had a 4th power, and then so the new polynomial will have a 3rd power because it goes down by 1, and then these new numbers become the coefficients of the terms. So our goal here is going to be to use synthetic division to reduce the polynomial until we get to a quadratic. Once you get to a quadratic, remember we have those methods of solving quadratics like factoring and the quadratic formula to figure out the remaining solutions. So just to review, to solve quadratics, remember you can solve quadratics by graphing. You can look for the x-intercepts to determine the solutions. You can use the quadratic formula, or you can factor the quadratic and use the zero product property to figure out the solutions. So why are we doing this? So we're doing this so we can graph polynomial functions that are in this form. So remember in the last lesson, we graphed polynomial functions that were already in factored form. Well, these polynomials are not already factored for us. So we're going to have to factor them before we can go through the steps we discussed last time in order to graph them. So you always want to start off looking for a GCF. Okay, so if there's something you can divide out of all the terms, you want to go ahead and start by doing that. So in this problem, I don't see a GCF. So now we're going to determine the possible rational roots. Okay, so I'm going to do my P over Q. And so the possible factors of 20, we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Okay, and then we're going to do the possible factors of Q. Well, there's no leading coefficient, so remember there's an implied 1 right there. So that's just going to be plus or minus 1. So that means all my possible rational roots are these whole numbers because they're all just over 1. So I need to try out some of these values to figure out what are the roots of this polynomial. So I'm going to start off by trying 2. So if I try 2, and I'm going to use synthetic division to try these out. And just remember, now I need to list out all the coefficients of these terms. Okay, so 1, 5, negative 4, negative 20. Okay, so remember, you bring down the 1, then do 1 times 2, which is 2. So we're going to do 5 plus 2, which is 7. 7 times 2 is 14. 14 plus negative 4 is 10. 10 times 2 is 20. So look, I have a 0 right here. Okay, so that means that 2 is a root. So if I write the associated factor, that associated factor is going to be an x minus 2. Okay, so I've figured out one of the factors. Okay, so now this 1, 7, and 10 gives me the coefficients of the depressed polynomial, right? So this is going to be, it started off as a cubic, so it went down to be a squared. Okay, so 1x squared, 7x, and then 10. So now I have this new polynomial, which is x squared plus 7x plus 10. So now I need to factor this. Well, it's a quadratic, right? So I know how to factor quadratics. I just need to figure out the factors of 10 that will add up to 7. So when I list out the factors of 10, okay, I need either 2 positive or 2 negative. Since 7 is positive, I'm going to need 2 positive factors. So the factors of 10 are going to be 1 and 10, and then 2 and 5. When I add up these factors, I get 11, and then here I get 7, so 2 and 5 is the correct combination. So that means that this will factor to x plus 2 times x plus 5. So now I just need to write all my factors together. So I've factored f of x. F of x is now x minus 2 times x plus 2 times x plus 5. Okay, so that is now the factored form of this polynomial that I have. I got x minus 2 from this root of 2 that I found, and then x plus 2 and x plus 5 from over here. So now we can go to graphing this polynomial, right? So this is not in factored form, so I'm going to go ahead and write the factored form that we just figured out. So now we go through the steps that we did in the last lesson. Start off by identifying the zeros. So we set this equal to 0 and then solve for the values of x. So I'm going to write this out. So we set each factor, remember, equal to 0. And now we solve for x. So here I'm going to add 2 to both sides, which gives me x equals 2. So I have an x-intercept at 2, 0. In this next one, I have x plus 2 equals 0. So if I subtract 2 from both sides, that gives me x equals negative 2. So I have an x-intercept at negative 2, 0. And then finally, I subtract 5 from both sides, which gives me x equals negative 5. So I have an x-intercept at negative 5, 0. So now I'm going to go ahead and plot these x-intercepts. So I have 2, 0, negative 2, 0, and negative 5, 0. Now I need to figure out the y-intercept of this function. Remember, the y-intercept is found by figuring out f of 0. So I have f of 0, so I have 0 minus 2 times 0 plus 2 times 0 plus 5. So that gives me negative 2 times 2 times 5. So negative 2 times 2, negative 4. Negative 4 times 5 is negative 20. So my y-intercept is at 0, negative 20. So I'm going to go ahead and plot that point. And now I just need to figure out some additional ordered pairs. So I have my x-intercepts at x equals negative 5, x equals negative 2, and x equals 2. So I just need to figure out some values that I have that are in between these points in order to figure out the additional points that I'm going to use. So between negative 5 and negative 2, I'm going to pick the point x equals negative 3. Between negative 2 and 2, I'm going to pick x equals 1. So when we do x equals negative 3, I'm just going to write f of x up here just so we remember. So we have x minus 2 times x plus 2 times x plus 5. So I first do f of negative 3. So when I do f of negative 3, I get negative 3 minus 2 times negative 3 plus 2 times negative 3 plus 5. So that gives me negative 5 times negative 1 times 2. And so I have negative 5 times negative 1 is 5. 5 times 2 is 10. So that means negative 3, 10 is another point on this graph. So let me go ahead and plot that point, negative 3, 10. And then now let's try f of 1. So we have f of 1, which is 1 minus 2 times 1 plus 2 times 1 plus 5. So we have negative 1 times 3 times 6. That's negative 18. So we have 1, negative 18. So let's go ahead and plot that point at 1, negative 18. And now we need to figure out the end behavior of this function. Okay, so the end behavior, we have a degree of 3, right? So it is an odd function. So that means it's going to go opposite directions at both ends. It has a leading coefficient that's greater than 0. So we would say that as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches positive infinity. Remember to use those charts that we went over in the last lesson if you have any questions about how I figured. So now I'm going to go ahead and graph this polynomial using that end behavior that we just figured out. So it's going to look going down in the negative direction. And then I'm going to continue connecting the points that I have. And then it is going to go up in the positive direction. So it's going to go something like this. So that's now the graph of this polynomial. So now you can go ahead and pause the video and try doing this problem on your own. So in this one, we have a GCF. There is an x that can be factored out of all the terms. So we're going to start off by factoring out that x. And then we're going to do the rational root theorem on the polynomial that remains. So the x cubed plus 2x squared minus 5x minus 6. So it gives us the possible rational roots, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So I started off by doing synthetic division on 2. And when we did that, we found that 2 is in factor root. So we have x minus 2, and then now the depressed polynomial is x squared plus 4x plus 3. And we can factor that since it's a quadratic, so we have x plus 1 times x plus 3. So if I collect all these factors, so I have these two, and I have x minus 2, and then I also have that x. So the factored form of f of x is going to be x times x minus 2 times x plus 3 times x plus 1. So I set my polynomial equal to 0 and found the 4 x-intercepts. And then I plugged in f of 0 to find the y-intercept, which is at 0, 0. I found some additional ordered pairs, and I used that to fill in the graph of my function. And then the end behavior, it's a degree 4, which is even, and the leading coefficient's greater than 0, so that means that it's going to head to positive infinity at both ends. So I used all of that information to sketch this graph of the polynomial. So remember, to graph polynomials in any form, you're going to start off by figuring out the roots using the rational root theorem and synthetic division. Once you've reduced the polynomial to a quadratic, you can use quadratic solving methods to find the remaining roots. You can plot the roots on the grid and then determine the y-intercept, and then graph the function using the end behavior and any additional points.